Clustering with constraints. So with constraints, we are looking at, for example, obstacles that may be in the path and whether you ignore them or you account for them. So this could be an example of ATM placement and where people can and cannot walk. And so if you're looking for the most optimal positions for ATMs in your town or water fountains or bathrooms, if you want to account for the fact that they can't walk through a building or across a raging river, that could change where you would want those placements of that ATM or water fountain or bathroom. And so taking obstacles into account or not could be a constraint type of clustering that you would do. So you can filter out scenarios that you don't care about, but ensure obstacles are in place and have the model account for that when it builds out the model. So constraints can be on a variety of different things. You can have it on an individual object. You can have it on a selection of your clustering parameters. You can use it on the similarity functions or the distance functions that we worked through. And so you can have also user-specific constraints on particular clusters. So one example of that would be containing at least 500 valued customers in that cluster and maybe 5,000 ordinary. So sometimes figuring out these parameters can take a little bit of time, some domain knowledge, and some trial and error, taking a look at your data and looking for those patterns that you're interested in. So why do we do this constraint-based cluster analysis? Well, a lot of times usually our users know their applications best. So if it is the ATM example, they know their town, they know where you can pass through and where you cannot pass through. And so using constraints can help really optimize what you're trying to solve, the problem you're trying to get at. So when we categorize our constraints, we can have different types of constraints on each instance. So in this example, we've got two examples of, this one's a must link, where these two must be linked in the same cluster. And then you can have constraints such as these two cannot be in the same cluster. They do not belong together. They should not be in the same spots. So you can cluster houses over $300,000 could be one example, and you can use these constraints based on distance. If you're looking for, it cannot link if it's more than a mile apart, for example. So constraints on our clusters, we can specify these requirements on these clusters. And so there could be a minimum number of objects required to be considered even a cluster, because otherwise you might have like a group of data instances, but it's not meaningful, it's not interesting. There are more outliers that just happen to be together. So you could have, a lot of times we have the minimum number of objects required to be part of that cluster, to make a cluster. And a max diameter of the cluster, so if you're trying to identify different clusters that may be close to each other, you might have a max diameter. The shape, if it's convex, we can also do some funky stuff with density-based, where it's can make some funky shapes. And then also the number of clusters. So normally in clustering, we don't necessarily have to identify the number of clusters up front for many of these algorithms, but sometimes you might have a specific number that you're looking for, or that you believe based on the domain knowledge that would work really well for that data set. And so you want to define what the number of clusters are that it should look for. So constraints on the similarity, this could be things like driving on roads and not going off-road, or taking a bike path, or some other path that's not allowed. And obstacles like walking across a raging river to get to an ATM may not make sense. So those can be constraints that you install. So a hard rule would be like cannot walk across the raging river. Soft constraints might be a little more flexible, that you could get across if it's not as bad, or walking through a building instead of having to go around it. You might find that some of the issues that come across with doing this with constraints is conflicting constraints, where you're trying to get like you want a set number of 5 clusters, and yet you have this constraint where the diameters between them must be at least X like 2 miles, and then suddenly like those don't, that actually won't make the number of cluster that you're requiring. So those are some of the issues you have to work through when you are working with constraint-based clustering. Some examples. And this is just a fun one as far as lane, finding a lane to go in when with lots of traffic. Of course, that's like a constraint-based model that we're trying to do with automated cars, and because you are confined within the road space and not hitting other cars and anything else that may be in the way. So that would be an example of constraints.